Okay, so the other type of sequences and series we're going to talk about, the only other type we're going to talk about is what we call geometric sequences and series. So in a geometric sequence, the ratio of any term to the previous term is constant. And the constant ratio is called the common ratio. And it's, common ratio, there we go. And is denoted by R. So, first thing we're going to say, okay, is a sequence geometric. Basically, with geometric sequence, we are looking for multiplication. Now, with arithmetic, we added. Geometric, we are going to multiply every single time. So, we're just going to say, okay, what can I multiply by a number to get from 4 to 10, 10 to 18, 18 to 28, and 28 to 40. Now, hopefully, you don't think of a number right off your head, right off the top of your head here. But there's another way to check to make sure it isn't like a fraction of some sort, because the constant ratio can be a fraction. So, just to kind of verify that it isn't, what we are going to do is we are going to divide the second term by the first term. Always that way. So 10 over 4, which gives us 5 halves. So to go from 4 to 10, we multiply by 5 halves. Like I said, the previous term divided by the next term divided by the previous term. Alright, so now I want to see, do I get from 10 to 18 by multiplying by 5 halves? Does that happen the same way? So what I'm going to do is I'm just going to say, alright, 18 divided by 10. Now, when I reduce this fraction here, I get 9/5. And basically, you're multiplying by two different numbers. It doesn't give us the same thing. So we're going to say, no, we have different ratios. And then for B, kind of similarly, so I go 6, 25, 1, 25, 25, 5, and 1. Now, to get the common ratio, we always divide the next term by the previous term. So I'm going to divide 125 by 625, and I'm going to get 1/5. Okay, so that's how I know I get from there to there. I'm multiplying by a fifth. Now, does it happen the same way going from with the next terms? So I'm going to do 25 divided by 125. This term divided by that term. And the answer is yes. 1/5. And you will see that that works for the other two as well. So, yes, and I would say my ratio is 1/5. So I'd like you guys to kind of figure out these two on your own. I'm going to say that this is yes, and I'm going to say that this is no when you do it and get your ratios. But see if you can find the ratio for this one on your own. So we have rules, just like we had rules for arithmetic sequences and series. So we are going to say the nth term of a geometric series with a first term of a1 and a common ratio r is given by, this one looks a little bit nicer than the one you saw the previous couple days. The nth term is equal to the first term times the ratio, that common ratio, raised to whatever nth term you're talking about, minus 1. So, for the little example I have in here, the nth term of a geometric sequence with a first term of 3 and a common ratio of 2, so is given by this formula. So any term of a geometric sequence with a first term of 3 and a common ratio of 2 follows this rule. Now, please note that I'm not multiplying 3 by 2 here. They are two separate entities. So do not make this 6. This is not 6. 2 to the n minus 1 times what 3 is. So just keep that in mind as you're going through. So I'll do 2 more of these, and then I want you to do the next 2 as kind of do it yourselves, do it on your own. So we're going to write a rule for the nth term of the sequence. Now sometimes you don't have to do that division thing. Sometimes it's kind of obvious. hopefully here you can see that you get to each of these terms by multiplying by 5. 4 times 5 gives me 20. 20 by 5 is 100. 100 by 5 gives me 500. So that ratio is 5, and 4 is my first term. So to create this rule, I'm going to say the nth term, any term, is equal to the first term times the ratio to the n minus 1. So for any n that I want. And then I say, let's find a sub 7. Let's find the 7th term. So I'm going to say a sub 7, and wherever I see an n, I'm going to plug in a 7, is equal to 4 times 5 to the 7 minus 1. So if I plug this in my calculator, 4 times 5 to the 7 minus 1, put this in parentheses, 7 minus 1, I will get my 7th term to be 62,500. Very large. You're going to get a lot of large numbers here because you are multiplying by a number. You're multiplying instead of adding. Now for part B, this may not be obvious right away. That's okay. We can use the rule. We can say, all right, I'm going to do negative 76 divided by 152, and that's going to be negative 1/2 when I simplify that fraction. So, and if you check that rule out for these two, you will find that it works the same. So negative 1/2 is my common ratio. So to create a rule for the nth term, this is my first term, I say the first term times the common ratio to the n minus 1. So that's my rule. Nothing else you have to do with it. And then if I find the 7th term, 152, negative 1/2 to the 7 minus 1. If I plug this into my calculator, 152, negative 0.5, negative 1/2, to the 7 minus 1, or to the 6th power, I get 2.375, or in better form, 19/8. So these next two I'd like you to do yourselves. I will give you the answers. We get, for this first one, my rule is this, 3 times 4 to the n minus 1. And then I'm asking for the 6th term. If you've done this correctly, the 6th term will be 3,072. For the next one, for B, my nth term is 36 times negative 1/3 to the n minus 1. And my 6th term, I end up getting negative 4 over 27, Alright. And the last example we're going to do on today's notes to end day 1 is kind of graphing them. So one term of a geometric sequence is, the 4th term is 12, and the common ratio is 2. Write a rule and graph the sequence. So they just say that the 4th term is 12. The first thing I want to do is create a rule. So I know that any rule for a geometric sequence follows this format. Now, I know, they tell me the common ratio is 2, that's nice of them. I know that the 4th term is equal to 12. I don't know what the first term is. I know that my r is equal to 2. And I know what my n is because they tell me I'm plugging in for this 4th term. So it's going to be 4 minus 1 in this case. So I'm going to say that I have a sub 1 times 2 to the 4 minus 1. So 2 to the 4 minus 1 is 2 cubed, which is just 8. So I have a sub 1 times 8 is equal to 12. And to get my first term, I'm just going to divide both sides by 8. And I get my first term is equal to 1.5, or 3/2. So to create this rule for the nth term, I needed that first term because they gave me r, 3/2 times 2 to the n minus 1. So that is the nth term. We had to work a little bit backwards here to get what the first term was to get the term for the sequence. Now, they ask us to graph the sequence. Now, to graph it, say this is part B, I separated it out as these are my x's and these are my y's. X represents the number you're plugging in, y represents the number you get out. So if I plug in 1 into this term, I know what the first term is. That's a sub 1. This is a sub 1, I found out to be 3 halves, or 1.5. If I plug in 2 for n, if I plug in 2 here, I get 2 to the first power times 3 halves, which gives me 3. If I plug in 3, I get 2 to the 2, which is 4. 4 times 3 over 2 gives me 6. And then I have, if I plug in 4, 2 cubed is 8. 8 times 3 over 2 is 12. Just plugging these numbers, these n's, into this equation. And then we can keep going. We get 5, 24, and you can go on and on and on. So we're just going to graph this. Like I said, these are my x's, these are my y's. We did something similar like this to arithmetic sequences. So I'm not going to put anything negative because I'm not going negative. So I'm going to space it out here so I can really see what I'm looking at. I'm going to go to 5. And let's see if this will work out. 2, 4, 6, 8, 10, 12, 14, 16, 18. I think I'm going to leave out this last one. I think I'll be able to see what I need to see without it. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So for my first term, I went to 1.5. So this is 1. So 1.5 falls right there. For 2, I went to 3. For 3, I went to 6. For 4, I went to 12. And then 5 went up to 24. Now, I'm not going to draw a line through these, but I hope that you can see that we have, in this case, some exponential growth happening here. We saw exponential growth and decay first semester. So that's what we have. That's what we'll see when we graph these things. Now, this one here, this is kind of your problem to do. We're going to end these notes. We're going to start up here for day 2. I'm not going to graph this, but I do hope that you can see that you will get a geometric, an exponential growth. I will give you the rule for the nth term, though. The nth term I get is 2/3 times 3 to the n minus 1. So, and then, like I said, you're going to go through that same graph that we did on the previous page and see what you get. You should get some strong exponential growth happening. We're going to stop it there. We'll pick this up tomorrow. We'll start here tomorrow, and then we'll finish up with this and then some geometric series. So thanks, guys.